do, do. Here we are. Another video. Horizontal asymptotes. So we know what an asymptote is. It's a line that a function approaches but never actually quite reaches. Okay? And so with vertical asymptotes, which you're familiar with, and now we'll talk about horizontal asymptotes. And horizontal asymptotes are sometimes called limits at infinity. Okay, as x gets really, really big. These are about end behavior of a function, not about what's going on, between negative 10 and 10. These are what's going on. If we zoom way out, what's happening with my function. Okay, so if as x approaches negative infinity, if the limit as x approaches negative infinity of some function is L, or the limit as x approaches positive infinity if some function is also was L, then y equals L is a horizontal asymptote of that function. So this function, as we get closer and closer and closer, get really, 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 really big, it heads towards 3. Okay, I don't know what the scale is, but we're talking about end behavior. This guy, my horizontal asymptote, appears to be 0. Okay, looking at the end behavior of this, and again, you notice that it passed through 0. It doesn't mean that we can't pass through the value, not like a vertical asymptote, we can never get there, but we can pass through 0. When we're talking horizontal asymptotes, we're talking about end behavior. Okay, don't be confused if the function passes through my horizontal asymptote at some point in the process. All right, end behavior. So generally speaking, as x gets really, really big, if I take a constant and multiply it by a big number raised to any power, I end up with 0. Okay? And so in this case, as x gets really, really big, so 2 divided by a really, really big number squared turns out to be essentially 0, so we end up with 5 minus 0, or 5. Okay, so back to a little talk about limits. So let's take a look at the limit here as we go through these. I'm going to do is I'm going to divide everything through by x. So this is going to become 2x over x minus 1 over x minus x over x plus 1 over x. Okay? As I do that, this turns into 2 minus 1 over x over 1 plus 1 over x. And if I take the limit as x gets really, really big, in this case, so x gets really, really big, this turns into 0, that turns into 0, so I've got 2 minus 0 over 1 plus 0, and I end up with 2 over 1, or 2. And so my horizontal asymptote is 2. So it means this function, as we get bigger and bigger and bigger, heads towards 2. I know what's going on in the inside, okay? In this case, what I'm going to end up with is I'm going to divide everything through by x squared. So I'm going to end up with 2x over x squared plus 5 over x squared, 3x squared over x squared, this is x squared, plus 1 over x squared. Magic. So here I end up with 2 over x plus 5 over x squared, that's a plus. Let's see, over 3 plus 1 over x squared. So as x gets really, really big, this goes to 0, that goes to 0, this goes to 0. So I end up with 0 plus 0 over 3 plus 0. So I end up with 0 on the top, 3 on the bottom, and that's just 0. Okay? All right, so again, this thing heads to 0. Similarly with this guy right here, so 2, I'm going to go through and divide everything again by x squared. 2 over there, like so, like so. That's a 1, right? Over x squared. This is going to be 2, this is going to be 0, this is going to be 3, this is going to be 0, so I'm going to end up with 2 over 3, or 2/3. Okay, pay attention, I'm going to ask you for a pattern. I'm going really quick here. I'm going to this time divide by x cubed. I always tend to try to clear out at least something, so I go with the biggest power that I have as I'm doing these. 3x squared over x cubed plus 1 over x cubed. So this thing's going to turn into 2. Agree? 5 over x cubed is going to turn into 0. This guy is going to turn into what? 3 over x, right? 3 over x is going to turn into 0. Okay? Plus 0. So I'm going to end up with 2 over 0. And we don't know exactly what that is, but we're going to just call it heading off to infinity. So this would be some sort of graph showing some unbounded behavior as we look at it, remember the words unbounded behavior, it shoots off to infinity. So it doesn't have any kind of asymptote or anything like that. It just keeps getting bigger and bigger and bigger. Okay? Doesn't have a horizontal asymptote at the very least. So, what have we learned? What have we learned? We learned in this case that, what did this one turn out to be? This one turned out to be, this one turned out, is that the one we just did? I think I could remember. No, that's not the one we just did. Oh, okay. So this one turned out to be 0. This is the one we just did. Infinity. So you have your notes. You can look back. Don't mock me. This one turns out to be 2/3. So what's the pattern? Okay, notice they're all pretty much the same thing. We always have a +5 and a +1. We always have 2 and 3 as my coefficient. The only thing that seems to change is the exponents. Okay, as I work my way through these problems. So what I want you to do is try to give me some sort of a thing. Okay. So if this, okay, and I'll give you a hint. It's got to do with the numerator and the denominator. So look at the numerator and look at the denominator, and even throw another word at you. Degree. Okay, so there are 3 cases. Case 1, case 2, and case 3. And if you can come up with the pattern, then you never have to do this work here again. You can just do these work by inspection. You can just look at it and go, oh, it's this, oh, it's this, oh, it's this. Okay? So try that. Come up with a pattern. I think if you dig back in through probably your math or advanced math, some place in the past you've done this, maybe pre-calc. Okay, what's the pattern? Bring that with you tomorrow. Okay, oops, I didn't want you to see that. Oh, there you go, a little limit sign. There's that, and that's it. Horizontal asymptotes in a nutshell in probably a few minutes or less. What do we got? 7 minutes. Modern record. So, thank you for watching. Hope you learned something. We'll talk to you tomorrow. Bye-bye. Bye.